This is Unit 5, Lesson 5, Deposition. So our learning target for today, I can explain how glaciers and water create different depositional patterns. And our success criteria, a student can compare the deposition from glaciers, running water, wind, and gravity, and identify whether particles would be sorted or unsorted. So when we look at depositional patterns, we're going to be looking at the way things are deposited. There are sorted and unsorted depositional patterns, and depending on the agent of erosion, whether it's glaciers, running water, wind, or gravity, you have different types of sorting and different ways that materials are deposited. So they may form certain kinds of structures, or they may be organized a certain way. So let's start off as usual with a definition. Deposition is when pieces of sediment, which is fragments of rocks, shells, and soil, etc., are dropped or put down in an area. Erosion occurs when wind, water, whatever agent of erosion is speeding up or gaining speed. Deposition occurs when it's losing speed. So the faster you're moving, the more things are moving with you. As you slow down, things stop moving, and that's deposition. So there are several factors that affect the rate and type of deposition. So the first is particle size. So the larger the particle it is, the faster it settles. So here you can see these larger particles are at the bottom. The shape of the particle, so the rounder it is, the faster it settles. So here we have rounder objects settling more easily. That has to do with the surface area and whether or not it experiences some kind of friction with the water or air. And then the particle density, so denser objects will obviously sink faster, which makes sense, right? Things that are dense are going to sink more easily than things that are less dense. So if we look at this set of images here, we want to think about, we only really have like one thing, we're looking at size, but if we want to figure out what the order is, so we'll start with C, because that's the largest, then A, then D, and then B. So these, because they're all the same shape, are really just being described by their sizes. So the largest particle C is going to settle faster than the smaller particle B, if we're thinking about like settling in water. So now we want to think about how sediments are sorted. So when particles are deposited, they are sorted or arranged in a certain way. There's two ways that they can be sorted. They can be sorted horizontally, or they could be sorted vertically, or they could be unsorted. So basically you're either going to be arranged in a certain kind of pattern that looks orderly, or you're going to just be random, which would be your unsorted. So here's an example of horizontal sorting. You have largest particles here, so this is a stream, this is an ocean. So here we have largest all the way out to smallest particles, so this is called horizontal sorting. We have vertical sorting, and then we have unsorted, so all these particles are mixed sizes. We'll start by reviewing what vertical sorting is. So vertical is going to be up, right? This tends to happen in areas with quiet water, like a lake, and there may be several depositional events separately. So this tends to be seasonal, maybe in the springtime when the water is moving very fast and you have a lot of erosion happening, then you have a lot of deposition happening. The deeper the water is, the greater the amount of sorting there will be, and this is also known as graded bedding. So there are several beds here. You can see every time you see a new section with large particles, that it would be considered to be a separate bed or separate like strata of our layer. So this tells us that these events happened over different time periods. This is just another example of graded bedding. Oops. So here is an animation that is looking at horizontal sorting. And so there is no sound here, but we could just watch what's happening. So you have a stream flowing. You have decreasing velocity, so the stream's slowing down. You can see what's starting to happen is these clay-sized particles, and remember, Clay is just named on, is just the size, right? So we'll just play this again. You can see how these are smaller, okay? These are sort of medium. These are gravel size sediments, so these would be larger. And again, these names just are based off of the size of the particle. So clay, sand, and gravel. So that is known as horizontal sorting. When a stream slows down, the largest particles are left behind first. Here are the largest particles. As the velocity slows more, this next smaller size will deposit. So this typically happens when an ocean meets a slow-moving body of water, a river meets a slow-moving body of water like an ocean. So you have a velocity in a river, a speed, it's moving relatively fast, and then it starts to slow down. So largest particles are going to be deposited first, all the way out to the smallest, which is clay. Here's just another example of that. Then we have deposition by rivers. So we're going to start thinking about how the different processes of erosion deposit differently. So we did talk about the sorting, which has to do with different types of materials, mostly rivers and water. But now we're going to look at specifically some depositional features. So a river delta, okay, this is a word we want to know, is a landform that forms from deposition of sediment carried by a river as the flow leaves its mouth and enters slow moving or standing water. So the mouth of the river is the end. All right, so as the water is moving out of the mouth into the ocean or the bay or the gulf, slowing down a lot, it's depositing materials. So this is an example of a Mississippi River delta here. So here's the Mississippi River. And then as the mouth of the river meets the Gulf, you have deposition. And it creates sort of this fan shape, although this is not, perfect, but creates kind of a fan shape depositional pattern or feature. So here is one that most people are familiar with. This is a historical map of Egypt showing us the Nile River Delta. So as the Nile River is flowing north, as it enters this body of water here, the water is slowing down, depositing all of these sediments. And then this is also where a lot of the cities are located in ancient Egypt, because this is, where there's a lot of green and there's growth. There's also transportation along the river. And then this is just satellite image of the Nile River Delta as well. To really see that like triangle V-shape formation here. So the Greek symbol delta is looks like a triangle. Then we have deposition by wind. So this typically is consisting of well sorted, so arranged by size, small particles whose wind can't carry big pieces, and they tend to be a little bit in layers, and this is known as cross bedding here. We have different layers. And it creates something called sand dunes, which is hills of sand deposited by wind. So this is our feature that's formed by wind, is a sand dune. Then we have unsorted deposition. So here is a video of a landslide. I know the quality isn't great, but I really like this video. So you can kind of see all of these different rocks here. Some of the trees are down. So when you have unsorted deposition, you have sediments that are deposited randomly with no arrangement by shape or size. This tends to be something like a landslide, like we just saw, or glaciers. Glaciers also don't really care. They just drop materials off in whatever order they get dropped off in. So we'll talk about glaciers now in a little more detail. So they are unsorted. These layers do not have sorting. And some of the depositional features that I want to go over are glacial till. So glacial till is material that is unsorted, deposited by ice. It's just piles of rocks, basically. Terminal moraine, which is the sediments deposited at the end of a glacier or the farthest retreat. So when a glacier advances, a continental ice sheet glacier, it advances or moves forward. When it starts to melt, they say it's retreating. Wherever it melts, it just drops off any of the sediments that it's been carrying, creating what's called a terminal moraine. And then we have something called drumlins, which are elongated hills composed of glacial deposits that show the direction of ice flow. I'll show you images of each of these. So this is glacial till. You can see it's unsorted, lots of different sediments, not super rounded when we look at the shape of the sediments as well. If you were looking closely, you might see some scratches there. Then we have the terminal moraine. So here is the Laurentide ice sheet. This is the last ice sheet that existed in the United States. It advanced all the way through parts of Staten Island. And this purple area here, this is the terminal moraine, or where the glacier stopped and left behind a bunch of materials. Also, these glaciers deposited moraines to form the North Fork and the South Fork of Long Island. So Long Island is built of a lot of glacial deposits as well as Staten Island, and I'm going to show you some images of that as well. So here's Staten Island, and we were sort of the last location of this glacier. As it moved south, it stopped moving somewhere mid-island, and before all of the buildings and roads and everything were built, you could see terminal moraine here. All this area is outwash, meaning it's melting and going out into the ocean, so that's why you've got some of that sand there. All these green areas are artificial fills, so they've been filled in by people to give us a little bit more space to live on. I believe, let's see. Yeah, so the only place left in Staten Island where you can see the terminal moraine is, I can't remember the name. There's a location all the way down here that's a park. And so if you actually were to go there, you could see some of that terminal moraine. Everything else has pretty much been dug up at this point. And then these are drumlins. So these are little hills. They're not big hills or little hills. They sort of have a tapered end, and the tapered or pointy end shows you the direction of flow. Again, you don't see a lot of things like this anymore because so much of the land has been dug up and built on that a lot of this gets removed. But you can see these in some areas of western New York where there's some large parks. They're visible a little bit. You might notice them. And then we have deposition by gravity. So we looked at this when we talked about sorting, but these are going to be unsorted, unlayered, angular fragments, so they're falling off the side of a cliff. Deposition by gravity is caused by landslides, rock slides, etc. So here's a rock slide. So for our learning target today, we wanted to be able to explain how glaciers and water create different depositional patterns and features. So think about the way that sorting happens between a glacier and running water. Think about the things that form, those landforms. And we want to be able to compare the deposition from glaciers, running water, wind, and gravity. Think about all those different features that form. Each one of those has its own kind of feature. And then thinking about whether the particles be sorted or unsorted.